Okay, so yesterday we learned about modeling percentages, and today we are going to move on to representing benchmark fractions and percents. Benchmark fractions are fractions that are going to help us identify fractions on a number line and just kind of give us a quick reference when we're comparing numbers in our everyday life. Okay, so let's look at this first part. It says practice making two equivalent fractions for each of the fractions below. Equivalent, if you'll remember, means equal. And we talked about in our journal yesterday, we wrote down the definition for equivalent forms. Remember, an equivalent fraction means another fraction that means the same, that has the same value. So 6/9 is 6 out of 9 parts. Well, I can make another fraction if I just think of either multiplying or dividing, because I can make my fraction get bigger or I can make it get smaller. I'm going to go ahead and just easy, I'm going to do times 2. What I do to the top, I have to do to the bottom. So 6 times 2 is 12, and 9 times 2 is 18. 6/9 is equal to 12/18. It said to make two of them, so let's make another one. I can also, let's use a different color so you can see the different one. I can also make 6/9 equal a different fraction if I think of another factor I can multiply by. Let's multiply by 4 this time. So 6 times 4, what I do to the top, I do to the bottom. 6 times 4 equals 24, and 9 times 4 equals 36. So 6/9 is equal to 12/18 is equal to 24/36. No matter how I say those three numbers are equal to the same amount. Okay, let's make equivalent fractions for 8/10. Again, the cool thing about making equivalent fractions is we can do anything we want to the numerator or the denominator. As long as we do the same thing on both, we'll find a new fraction. So let's go ahead and do times. I'm going to use the dot. That's another symbol for multiply. I'm going to say, let's do 3 this time. What I do to the top, I have to do to the bottom. 8 times 3 equals 24. 10 times 3 equals 30. So that's one equivalent. That's an equivalent fraction. Let's do one more. 8/10. What if I multiply by 2? What I do to the top, I do to the bottom. 8 times 2 is 16. 10 times 2 is 20. Okay. 5/4. Let's do times 2. What I do to the top, I do to the bottom. 5 times 2 equals 10. 4 times 2 equals 8. And all of those numbers says how do the fractions you wrote compare to the original fraction. So we started with 6/9. We made 12/18 and we made 24/36. How are they comparing to each other? They all equal the same amount. 8/10 started with 8/10, then we got 24/30, and then we got 16/20. What is the connection between the three of those? It doesn't matter how you write it, they equal the same amount. Same thing with 5/4, 10/8. It's the same value. Okay? All right, so they, whoops. equal the same amount. Okay. It's important to know equivalent fractions for percents, because now we're going to have to think about how can I make a percentage if I have a fraction that is not over 100. We have to know how to fix that so that we can have a percentage, because remember, percent always has to be out of 100. Okay, so converting fractions to percents. Okay, a fraction can be written as a percent when the denominator is 100. We already know that. We learned that yesterday. If the denominator is a friendly number, you can scale up or down or use a proportion. We wrote this word in our vocabulary in the journal yesterday. Proportion means when you're making a comparison between two numbers. Okay? All right. Convert each fraction below so that the denominator is 100. So we know we have 6/20ths, and we want it to equal a fraction that has 100 as the denominator. So I have to ask myself, if I went from 20 to 100, what type of math did I do? How did I get from 20 to 100? Well, I know that 20 times 5 equals 100. So if that is true, what I do to the bottom, what I do to the bottom, I have to do to the top. I multiplied by 5 on bottom, I have to multiply by 5 on top. 6 times 5 is 30. So 6/20ths is equivalent to 30/100ths. And that's just going to make it easier to find a percent because it's out of 100. All right, let's try this next one. 7/10ths. Since I have to work with percents and it wants me to write a fraction, we want our denominator to be 100. What did I do to the denominator 10 to change it to 100? It got bigger, so that means I multiplied by something, right? What times what equals 100? 10. And the rule is, what I do to the bottom, I do to the top. So since I multiplied by 10 on bottom, I multiply by 10 on top. 10 times 7 equals 70. And again, we're making it a denominator of 100 because we want it to be a percent eventually. And percent is always out of 100. All right, let's do 3/4. What does it have to equal? 100. Awesome. Okay, what times 4 gives me 100? You should have said 25. It's like having quarters and a dollar. It takes 4 quarters to make a dollar, or 100 pennies. What I do to the bottom, I do to the top. So now I have 25 times 3. 3 times 5 is 15. Carry the 1. 3 times 2 is 6, plus 1 more is 7. So we have 75 hundredths, 3/4. Complete the tables below. Fraction is 3/25ths. We want in the middle, we want to write a fraction that ends or that has a denominator 100, and then we want to convert that into a percent. So if I have 3/25ths, how am I going to make that equal a fraction that has 0 as or 100 as the denominator? What times 25 equals 100? 25 times 4. What I do to the bottom, I do to the top. 25 times 4 equals 100. 3 times 4 equals 12. And yesterday we learned that a percent from a fraction is the part to the whole. 12%. What part is 100? 12% is. All right. 35/50ths. How do I make that a fraction that ends or that has a denominator 100? Good. 50 times 2 equals 100.